Okay, 5.4a, we're gonna just review how we use integrals. So now it's gonna be starting to do what's the purpose of having an integral. We know that we can use integrals to find area, but we can also use integrals to accumulate other rates. So if we're given any rate, then we should be able to use an antiderivative or an integral to find the total of whatever's being accumulated at that rate. So A being not just area, but A being an accumulation. So if you're working on gumdrops per hour, that's your rate, you accumulate those, and then the antiderivative would have a unit of gumdrops. Or if you're looking, make sure you know how to work the units. Like if the unit is gumdrops per hour squared, then the antiderivative is just going to be gumdrops per hour, and the antiderivative of that would be gumdrops. Okay, so here's an example of water. If we have a water being pumped into a tank at a given rate, and the rate is gallons per hour, then an antiderivative will convert that into just gallons. So you set up an integral to find the accumulated total. Your integral will go over the time units from 0 to 3. Make sure you put parentheses around the cubic function. And then your differential is dt, not dx, but t is the variable. And then depending on what tools you have, if you have your calculator, then you can run this through a Math 9. If you don't have your calculator, then you would be running it just through straight out antiderivatives. Most of these are going to be calculator because the functions will be more on the complex side, okay? Because real life ones are rarely very nice. So if you run this over the 3 hours, you get 21.75, and then the units on that would be gallons of water pumped into the tank. Now, if this had come out to be negative, then we would have known that the gallons of water were draining out of the tank, so the accumulation was less. We also can use antiderivatives to find total area as opposed to net area. Total area is just always making sure you include an absolute value. The absolute value has to go inside the integral. So occasionally I will see someone set theirs, if they're going 0 to 6, 4 minus x squared dx, that's a parabola. Part of it dips below the x-axis. I'll see them do this. That's not going to give you total area. That's going to take the net area, whatever it is, and just make it positive, which is not what total area is. So that would not be the right way to set that up. Your absolute values need to be on the inside in order for you to find the total area. Now, if you're doing this without a calculator, then you would just type that in straight with the absolute value bars. If you are doing it without a calculator, you want to approach this graphically. If we're going 0 to 6, oops, what shape do you know this to be? Upside down parabola starting at the number 4. Where is this going to cross the x-axis? Okay, at 2, so it's going to come down cross. It's not a very good parabola, is it? Cross at 2 and then go way down here. So without a calculator, you would need to split this up. So you would run 0 to 2 like normal. And then if you wanted total, you'd have a second integral to cover the negative part. Now, if you just did 2 to 6, that's going to give you a negative number. Okay, so you don't want to just do 2 to 6. What could you do to that integral to make sure you get a positive number instead of a negative number. A couple things you could do. You could switch the bounds. Okay, that would be one thing, is that you could do the bounds from 6 to 2, and that would make sure that you get a positive number. Is there anything else you could do that would, what if you kept the bounds the same? We can't integrate an absolute value. We're trying to do this without a calculator. And then change it later. Okay? Any other way? Is there anything else you can switch?
Can you just like subtract?
Okay, so we could keep it as 2 to 6 and then do a subtraction. That would also cover it. So any of those, if you're working without a calculator. So if you get a calculator, make sure you know where to put the absolute values. If you don't have a calculator, so you can't use absolute values, make sure you would know where it would be negative and then how to handle the negative area so that you can come up with the correct total. Like this. Yes, over just that part. And then you may evaluate it normal and then change it. So that accomplishes the same thing as switching the bounds or subtracting. Those will both do the same thing. Here's your question, Zach, from before, like what the FN int or N means. That's just math 9, right? So you can run that. If you've got your calculator, run it on a math 9, just to make sure to put the absolute values on the interior of your function.